we're going to be working on decimals this week, review for some of you, first time for some others. Decimals are much easier than fractions, but they are the same thing. Decimals are still a way to represent numbers that are smaller than a whole, smaller than 1. Between 1 and 2, there's a lot of space depending on where your 1 is and where your 2. And that space can be divided. It has to be quantified because, as we talked about age, a person that's born at 12:01 and a person that's, the next person may not be born at 12:02. They may come right after 12:01. You see what I'm saying? And so that time has to be quantified. You have to have a way to express what that measurement is. And fractions and decimals are ways to express that. Decimals, the first part of that word, DEC, you need to remember all the time that that's good for reading and vocabulary as well. When you see DEC, what does it mean to you? What does it give you? What kind of meaning does that give? Anything that starts with DEC? 10. 10. So when you talk about decimals, you're talking about something that has to do with 10. Decade, 10 years, you see, dec. December, the 10th month, right? Why isn't it the 10th month? Well, while she's thinking, what about oct? What does oct mean? What does oct mean? 8. October is the 8th month, right? Okay, one of you needs to tell your classmates why, in this case, DEC is not 10, it's 12, and oct is not 8. Septuplets are how many? 7. September the 7th month? Okay, I'm giving you time to think.
I just remember something about Julius and Augustus.
Julius and Augustus. Julius and Augustus Caesar. They're famous because they were Romans and they did a lot of conquering in the old world and conquering different territories, and they were very great. I know you've heard of Caesar before. Well, Julius Caesar is who you mostly hear about, but Augustus Caesar was also great, and they were honored by having months named for themselves, and they put them in the middle of the year instead of just tacking them on to the end. The year used to be divided into 10 months, and September was the 7th month, and October was the 8th month, and December was the 10th month. But they got pushed down 2 months because of Julius, which is what month? July, and Augustus, which is August. So that's the reason. But in most cases, DEC, when we talk about DEC, we're talking about something that has to do with 10. And our number system that we use is based on 10. You can we're in the base 10, as a matter of fact, and there are all different bases. Computers operate on the base 2. And they only have 2 numbers, 0 and 1. We're in the base 10, that's why we don't have a number 10. We have the numerals 0 through 9. And then we get to what's called the base. We're in the base 10, so the base is, we have 1 of the base and no units. And we call that 10 because we're at the base 10. If you were in the base 5, 1 0 would represent 5. It would be 1 of the base and no units, you see. But since we're in the base 10, we've given these other numbers 10, 11, 12, 13, and so forth, even up to 20 and 90 and whatever, we've given them names. But what this says is that here it says you have one of the base and one unit. And because we're in the base 10, we call that 11. This is one of the base and 2 units, okay? This is 2 of the base, 2 tens. In any base, the way numbers go, we put a comma there just to make for ease of reading. The first number are your units. So those are our ones. The next number is our base. These are our tens. The next number is always your base squared, or 10 times 10. That's our hundreds. The next level is your base to the 3rd power, which is 10 times 10 times 10, which is 1,000. The next is 10 to the 4th power, which again, 10 times 10 times 10 times 10, which is 100,000, and so forth, to our million and whatever, okay? So, in our system, in our number system, each number, the place that it's in, tells us the value of that number, okay? Tells us the value. We know we have 4 tens here, we have 3 hundreds, we have 0 thousands, we have 2 10,000s, and so forth. Decimals are the same. Decimals are 10. But they're separated. The units are on this side, and then on this side you have fractions. Instead of having tens, you have tenths. It's actually 10 to the negative 1. Okay. Next to that you have hundredths. It goes the same way that way as it went that way, but now they are part of the whole. A tenth means it takes 3 of these. It's going to take 10 of these, 10 of these to make one of these, and you have 3 of them. And if you think about our money system, it takes 10 dimes to make a dollar, right? It takes 10 pennies to make a dime. In this system, everything, it takes 10 of to make the next one, 10 of to make the next one. But because it's the same thing going this way as it is going this way, decimals are usually easier to work with than the fractions that we worked on last week, because with fractions, again, the denominator can be anything. That can be a 7th or a 13th or a 15th, so you can't have a system like this. But in the decimal system, it's tenths, hundredths, thousandths, still goes up by the 10, powers of 10, 10,000ths, 100,000ths, millions, 10 millions, 100 millions, and so forth. It just keeps going that way just like it goes this way. But the place, hello Francisco, you eased in here. The place that the number is in gives its value. Decimals are easy to read. They should be easy to read, but you should not read that number 0.34. If you read that number 0.34, that gives you no value. It tells you nothing about that number. You have to learn to read this number 34, and what they are what? 34 what?
34 hundredths.
Hundredths, because it's in the hundredths place. 2 numbers past the decimal are hundredths, tenths, hundredths, thousandths. Easy to know because however many there are here, there are 2, that's how many zeros. That lets you know they're hundredths. See? How would we read this number? How many of them do you have?
Thousands.
How many?
345.
You have 345 somethings, you see what I mean? 345, if I tell you you ask me how much money I have, and I say I have 345,
You got some money.
maybe. It could be 345 pennies, which is $3.45. You see what I'm saying? It could be $345. It could be 345 nickels. You see what I'm saying? 345 doesn't tell you anything, should not tell you anything until you know what the 345 is. 345 is just the numerator. It tells you how many. It doesn't matter if it's written like this or if it's written like a common fraction. That's where that is at the top. That's how many of them you have. The place that it occupies tells me what they are. This is 345 what? Thousands. It's 3 zeros, right? 3 numbers past the decimal. 345 thousandths can be written like this, or it can be written like this. The difference between a common fraction and a decimal fraction is that a decimal fraction will always have as a denominator a power of 10. It has to be a tenth, a hundredth, a thousandth, a hundred thousandth, you know, a 1 with zeros next to it. Always has to be the denominator when you're dealing with decimals. When you're dealing with common fractions, that denominator can be anything. So it's easy to work with decimals because they look just like whole numbers that you've been used to working with. And so it shouldn't be any harder to work with fractions, common fractions, than decimal fractions.